Hey everyone, welcome to the Tom's Hardware Podcast for April 5th, 2022. As always, I'm Tom's Hardware Editor in Chief, Avram Pilch, joined by Associate Editor Les Pounder, Raspberry Pi expert Ash Hill, and our very special guest Anton Titov. Anton, thank you so much for joining us.
Thank you guys for inviting.
So, Anton, you have been working using Raspberry Pi for a very special purpose. Can you tell everyone about that?
Yeah, let me actually just show this thing as well. So I've been using Raspberry Pi for a while, uh, and in different projects, and there's always been a need for me to actually connect Raspberry Pi or an Arduino or anything else to the pack of sensor, pack of things, which always require some type of USB. So I got very lazy making this USB all the time, making like photo templates, applying them to PCB, applying masks. So I tried to essentially cut the corners and try to combine the applying the mask process and the actual like photolithography process into one box. So this is Meduza. This is essentially the device which very similar to UV filters, which you can print with just normal resin. It has 2K monochromic screen. As you can see, it's saying Meduza. I'm not sure if you can see the text here.
Yeah.
Uh,
Yep.
well, nice looking case, and that's basically it. The process, like visually, it actually looks very simple. So what we can do, since this is Raspberry Pi, it actually runs full-blown web server with a software created to actually make this machine work properly. So if you can switch for a second, I can actually demo to you what actually sits inside this box. So this is a UI which has been created for this machine. In this UI, I'm able to upload, well, Gerber file. You can get Gerber file from almost any PCB creation software like EasyEDA, DeepTrace, KeyCut, Eagle, whatever. They're all kind of the same format. Once you upload this Gerber file in here, it will automatically render previews. It will show you which layers you have. And then all you have to do to actually manufacture this PCB, well, you have to click manufacture. This is two-sided PCB. So actually, let's try to use a single-sided because I have only one side to show. So, well, USB ASP classic one. So if I want to manufacture the PCB on this machine, all I need to do is just enter the stock size. Let's say something like that. I'm going to select like the coating for the photoresist. I can use the default kind of exposure time, which I calibrated for this particular batch of photoresist, or I can essentially enter the custom one. This is useful when I'm testing new coatings. I can also do the second sweep of the soldering mask. So this device can do both. And let's say it's going to be 10 seconds exposure. So all I have to do now, just click start fabrication. And if you can tune back to the device, you can probably see it's now going to generate the template. So now this device is actually showing the template on the screen. This is currently a red one. I hope you can see it.
Mm-hmm.
Yeah.
The resolution of the lines, like in theory, up to 50 microns, practically, well, 100 is probably the minimum size I can do with this type of etching. Well, then I'm putting any type of PCB with photosensitive coating. In this case, this is just some card with cheap coating from some store just to like glow in the dark. All I have to do is close it, and here we go. The exposure process begun. There is a nice looking progress bar, and I can also see the status within the software. What is it doing now? It is doing the first layer exposure.
Mm-hmm.
I was hoping the LEDs did more than look cool. That's neat that they work as a progress bar.
So
Nice,
now this is complete, and I'm not sure if you can see. Oh yeah, you can probably see it. So like this is essentially the areas which was lighted with UV light. Well, since we have mask selected, the device is now asking for us to etch the PCB, and this is, for right now, this is a manual process, but I'm planning to actually automate this part as well. I can click on the bottom, and it's going to now render the mask layer. In this case, as you can see, it's been automatically inverted because the coating for that is inverted, and yeah, and I can probably do the same. So if I'll turn it on, you can see that UV light is essentially glowing from it. So now it is doing the mask part, and that's it. Essentially, the whole process of converting the PCB to the template, rotating it, inverting it, applying it. It's been I've been too lazy to replicate it every time. So that's a device for that.
Wow, that's really impressive.
I was just thinking, how long does it take to do a standard, a very simple PCB? So from picking it on the machine to having something in your hands that you can solder up and build.
Well, I don't think this device is intended to like sell made PCBs. It's mostly like for prototyping purposes. But my record was around 21 minutes for the single-sided PCB with mask on. And like most of this time is just waiting for the etchant to complete work. Like making the mask take 2 minutes, making the actual actual photoresist work around 60 seconds. In this case, I used 20. So like most of the steps just waiting for it to wash away or wait for etching to complete.
Very nice. That's really quick, I have to say. It's useful that you can prototype a PCB so quickly, because we're now living in a world where it's so easy to just chuck a PCB design on easy EDA or just do something in KiCad and send it over. I mean, I do that myself. I've got very poor quality one. Not the board, but my design. There you go. That's a PCB I made last year. Just simple little breakout. Let's get it in focus. There we go. Very simple little breakout. That took me about an hour in KiCad to work out. But it took about a week and a half to come back from Osh Park in the States.
So, Anton, the Meduza is using a Raspberry Pi 4, is that correct?
This is correct.
Okay, and why the Pi 4? Would it work with an older module?
Yeah, actually, it would work with all the modular. I just didn't have any like spare at the moment. But the CPU utilization on this device like up to 10%. So it has a pretty much a lot of space. Well, for smaller Raspberry Pi. The only issue is that the display is like too large for the 32 bits type of OS. So you have to use 64 bits to make it work. That was one of the biggest hurdles when I've been building this device.
So that would make the Pi 4 ideal for that 64-bit support.
Yes.
Yeah. I wonder if a Pi 02W could be used with it, because that's 64-bit CPU. That could be a cheaper alternative.
I think it is possible, yeah.
Yeah.
I believe that at least 1 gigabyte of RAM will be enough to make this device work.
That takes the 02 out of the equation, then, so we need a 3B plus probably to do that then.
Yeah.
Yeah, no question about that. So I'm really impressed with the design and the case. Did you repurpose that case from something else, or did you 3D print it?
No, I just made it. I firstly made it the name, and then essentially come up with the case. Let me show it in a bit more details. So the device, the Meduza name came obviously because it hardens everything it sees on. I tried to make a logo up front, but it kind of didn't print well. So all you can see here is just a standard 3D printed case. But because I added these lines, it looks, a little bit better. And there's also labyrinth at top. It's actually a valid labyrinth. So if you borrow it waiting for the PCB to complete, you can just go and try to trace it.
That's good. How did you generate the labyrinth? That's really interesting.
There's actually online tools which can export you the labyrinth in SVG, then a little bit of Inkscape, then import it to something like Fusion, and as a result, you have the labyrinth work. Clever. This part is done on the magnets. There is 2 bearings just to make this height work, and there is a 4 powerful magnets at each side with some like rubber spacer here. So like every time I'm placing the PCB, it basically makes kind of consistent pressure across it for all the screen size. So like the biggest PCB I tried to make is probably maybe like I would assume it's gonna be 3-inch by maybe like 3-inch, something like that. So it was no issues with seeing the traces across all the surface of the PCB.
So how much does that cost to make, and how much do the raw materials cost to make a PCB?
Well, I mean, you can make the raw PCB. I mean, very, very cheap. You buy the photoresist and the actual like raw copper, maybe like for $10, at least locally here, and that's going to be enough for you for maybe like 10, 20-ish PCBs. So like that's basically all your expenses. I mean, a little bit of chemistry, but it's going to last even longer. You can etch PCB in different solutions. Some of them you can basically build from the grocery store. Some we can buy from the lab store, but none of them are expensive. So I would say that a single PCB at home is going to cost maybe like $0.50 to produce maximum. Obviously, if you like bought everything ahead of the time and prepared PCBs with photoresist, which saves a bunch of time. If you're asking about the device itself, that's a little bit harder to calculate. Excluding the labor and just coding work, the most expensive parts here are screen and unfortunately Raspberry Pi these days. When I bought this Raspberry Pi, it was much cheaper, but I think it's very hard to get these computers available. So it's probably going to be $100 for the display with driver and maybe $100 for the Raspberry Pi as well. Else you'll need some spare parts, obviously LEDs. So like there is a red light which creates some way of like positioning guidance system plus nice logo, and there is UV light plus drivers for both. So it's maybe around $20 in addition to all the stuff. DC-DC converter $5. So I would assume like $250 is going to be enough to just get raw materials and raw equipment to build this device today. Plus plastic cost, but I'm not sure how to calculate it. So it's not the cheapest exercise, I would say, but saves a lot of time for me.
No question. I don't know how much it costs to buy something like that off the shelf. So it's probably, I don't know, Les, have you ever looked into that?
Not really, no. I've usually just gone to PCB houses and had them fabricated that way, because it's just easier. I haven't really got the space to have a PCB setup, unfortunately.
Neat. So, Les, Ash, what questions do you have for Anton?
Okay, so this is simple, and I kind of touched on it earlier. I really like the LED strip on the front, and I know that it functions as like a progress bar as you print things. Does it do anything else? Does it maybe flash whenever you're connected to Wi-Fi or anything like that?
Actually, it does. It first shows you the progress bar when it boots the device. So let me just try to turn it off and turn it on. This is off, and now you'll be able to see that it actually indicates the booting status, just for the very impatient people. It also shows time when it requires user intervention. So like you see this progress bar, but when essentially the device asking you to press a button or wait for you to etch, it is going to show a different type of pattern. And if there's going to be an error in a software, it will also flash like blink red. But I'm not sure how to show this thing, because I'm not sure how to cause error this time. It was very useful when I was building it, but now it's pretty much stable. So it actually this whole strip works not directly through Raspberry Pi, but there is an I2C bridge to Arduino to actually drive it, because I didn't manage to get a proper PWM control for the LEDs and PWM control for the UV and red lights. Like Raspberry Pi in this case didn't kind of match my expectations, and I had to fall back to the Arduino.
So what were your expectations for PWM on the Pi? I mean, was it not good enough? Was it not quick enough? Was it not a granular enough control?
Well, first of all, there's only 2 channels, and I have to dedicate one channel to actually like highlights. So like 2 of them already busy. But even when I try to use one for the red light and the rest for this LED strip, I've been building software in Golang as main language, and the bindings for the Golang was in conflict with the library for the strip. So I had 2 options. Either I'm going to dedicate it to the Arduino and also add some kind of temperature sensor or other stuff, or spend a couple of weeks trying to glue one library on C++ and one on Golang. So I decided to go the hardware route.
No problem. But it's interesting you choose Golang. It's not as popular a language on the Pi, if you pardon my choice of phrase there. Whenever you think Raspberry Pi, you think Python. So why has Golang got an appeal to you?
Well, I mean, it's much faster, at least. So I mean, it has almost all the bindings you have on Python. Obviously, you can't train the, let's say, Keras or TensorFlow on it, but you can run models. You can embed them to Golang. The overhead it's a binary file, so that you don't need to install Python and have conflicts between versions. I apologize. And also, as I mentioned, it runs much faster. So I managed, for example, to put the image capture server, the video stream server, and controls for the remote mounting server within a program on Raspberry Pi Zero, and it worked with 20% CPU utilization. I'm not sure. I mean, I can do it in Python, but I think Golang is going to give a much bigger room.
That sounds great. I've dabbled with Golang in the past on a Pi and also TinyGo on an Arduino, and I found it to be a really nice language to play around with. It feels very comfortable to use and very safe, and you can understand how everything works.
Yep.
So we have a question from the audience. Barry asked, "Is there a tutorial for the Meduza?"
I guess if I'll open source this device, sell it, it's going to be a tutorial for it for sure. So far, it's just from mouse to ears, I guess. So. Unless you mean tutorial to build it, yes, I can. I'm working on actually finalizing the software, and I hope to open source like the models and the connections and the PCBs and the software someday on GitHub.
Another viewer asked, "Are you going to make it commercial or probably open source?"
I'm definitely going to make one of this. Which one I haven't decided yet.
That makes sense. So, speaking of things that are interesting to look at, Les, you've been testing out a new camera, correct?
I have, yeah. It's an AI camera, so it's not just something that takes a pretty picture. Not that my face is a pretty picture. I'm going to show you a close-up now. It's the Vizi from Charmed Labs, and it's unusual. It looks like a bright green CCTV camera, but it's got a Raspberry Pi 4 4GB inside of it, and the HQ camera as well. And it's got a nice little lens on it as well. If I just turn it to the camera there, you can see. There you go. You have a focus ring as well. Just here, that's locked at the moment. And just to prove it is, Raspberry Pi 4. You've got some dedicated breakouts on the side for 12-volt outputs and also for some basic GPIO connection. You don't get all of the GPIO because inside of here there is another board called the Vizi Power Board, which is working on 12-volt power, which comes in via a DC jack on the side. I'm not using that at the moment. But it also has connections for a fan. There's a heatsink in there as well. For this demo tonight, I've turned the fan off because it's particularly loud. It's at full power. It just goes full power. Right now, this is at about 75 degrees C inside of here. It's running a bit warm. The AC is to put off the thermal throttle. So I'm going to swap to the camera now, another angle, and you get to see me twice now. You're all very lucky. And right now, it's running some TensorFlow, it's object identification, and it's seeing that there's a person there. It's pretty certain it's a person. It's me. I hold up an object, so a banana. It's 97% certain that's a banana. It's an object recognition, and it's all done in TensorFlow, and it's also TensorFlow Lite as well. This is normal TensorFlow. And I can change this on the fly to another demo. So if I just go to that window now and click on the section up here and go to the examples, and you can see, oh, it's TensorFlow running. There we go. There's TensorFlow Lite, which is very similar, a little bit of a lighter version of TensorFlow usually for microcontrollers and lower speed processors. That's just plain normal video. And if we go to the first one, edge detection, if I run that now, see the image disappear, and it'll come back with something quite interesting. So it's detecting objects as lines, and it's showing the video image. And it's quite clever. So if I hold the banana again, you can see the banana, but this is a black and white image. I find that really cool. But there are
me of a music video for Take On Me.
I remember that as well. Yes, aha.
Aha.
There you are. So I'm going to run one of the examples now. This is a bird feeder. So this is designed as an AI smart camera. So it's not just taking pictures. It's there to look at objects and try and work out what they are. So it's got a model programmed into it, and the bird feeder is looking for birds. Sadly, it's not going to look out the window right now. I haven't got enough wire to take it all the way to the window for the demo. So it might show a few issues with me coming up to the screen. Before, it was calling me like a woodpecker type bird. I have no idea why. There we go. Cedar waning, I think it's calling me this time. But it can scan an object, so it can see if it's a bird or not, and if it is, it can identify what type of bird it is, if it's in the model. It can also take a picture or a video automatically. There are buttons on the bottom here, but it can also do it automatically, and it can save those images to Google Cloud. So if you've got Google Docs or your images on Google's cloud services, put them straight there. We've also got into this, which I think is quite cool. It's a little bit slower than normal, but it's really handy. We've got a Python console and a shell. So you can see here I'm messing around with the power monitor script to stop the fan from coming on during the video. But it's all really interesting to play around with and sort of test how far you can go with AI and TensorFlow with a board such as this, and then see if you can produce some interesting images and videos that will automatically classify an object and then put it online somewhere that you can look at for another device or later on. It's going to demonstrate how loud the fan is. Are you all ready?
Yes.
Can you hear
Oh,
the
it's
fan?
ready for takeoff, yes.
That's the full power, the fan. It's really loud, but it keeps the Pi decently cool. Whenever it's doing TensorFlow work, it's really intensive, so the CPU is just going crazy. So it's going to get hot. But interesting product. I'm doing a full review of it this week. It'll be on the site this weekend, and I think it's interesting to play with. So people should have a look at this at the weekend.
Great. Anton, have you done much with image recognition and AI?
Actually, yes. I built a robot which collected a bunch of samples for the lab tubes, piped this to the TensorFlow, created a model, then normalized it, uploaded to TensorFlow Lite, and there is this like little frame in the background which later run through the samples and recognize which contains something and which doesn't. So I have some little bit of experience with that.
That's neat.
Very cool.
Very, very cool. So do you, so Les, how would you see this being different than just being far superior to taking something like a Raspberry Pi HQ camera or regular Raspberry Pi camera and installing TensorFlow on a Pi 4 and running it without this?
I think it's the all-in-one nature of the product. It's all built, ready to go. So you've got the enclosure to put everything in. You've got the cooling system set up. You've even got the 3/4 inch screw mount on the bottom to support the whole unit or to put it on your own tripod somewhere else. You haven't got to worry about it. It's almost as if you're buying a kit ready to go to build the project rather than building all the elements together into your own kit.
That makes sense. So I mean, it's pretty cool what you can do with that, because then obviously one of the biggest problems that people have that Anton has done such a great job of solving for his project is it's one thing to program something and to wire it, but another to make it into a functional product with a case and a nice UI like RGB lights that light up and things that can mount on a stand. Like that requires design expertise, which some of us don't have. So,
And it's got the
Yeah.
breakout on the side, so I could see that being useful in a classroom if somebody wants to tinker with a few different kinds of Pi projects with their students.
yeah,
Yeah.
that's really cool. So speaking of tinkering, Ash, you have been tinkering with Grafana, is that correct?
Grafana, yes.
Oh, Grafana.
I looked up a video to hear the CEO say it right because I would have butchered that. So if you've not heard of it before, Grafana is a platform used to create custom dashboards that can display all sorts of data. I've come across Grafana over the years as we cover Pi projects, and I've never really dabbled into it until just this week. So it's really easy to link with Raspberry Pi and projects like anything that involves data that you want to analyze visually. So you can make bar graphs, charts, things like that update in real time. There are paid options, but it also has free services, and the free services have enough tools that you can tinker with on the Pi. So I'm having some hardware issues with my physical Raspberry Pi, but I've got a virtual one set up over here that's working pretty good. And I did set up Grafana on it earlier this morning. I played around with it some. I got it. There we go. Yeah, this is a live feed of my virtual machine. But what I'm going to do is pull up a web browser that can access the Grafana dashboard building service. And here's what it looks like. And it's really user-friendly. It's completely drag and drop, which I think is what makes it user-friendly. I can grab this board and move it over to this side, or I can resize it to make it smaller, and it's easy to add new panels. And as you add new panels, you can determine what kind of panel you want it to be. Do you want it to show a specific statistic of the data that you're gathering? Do you want it to be a gauge, things like that? Maybe you're monitoring your processor temperature, something like that. And then once you apply your settings, you can link it to a specific, maybe you have a module on your Pi or a specific application that you're getting data from, and then you could just build your own dashboard. And I thought it would be useful if I could give you guys a few examples of what they look like put together. So I have a couple of Raspberry Pi projects that we've covered before on Tom's Hardware that uses Grafana. So the first one I wanted to show off here was this, it's a Raspberry Pi they're detecting cosmic rays from space with, and they're using Grafana to show where on the map the rays have been detected. You can see the bar graph right here, and you can add text and details about it. So if other people wanted to know what this data is representing, you've got something there to explain it. Another one here was detecting earthquake data using a Raspberry Pi, and they just used Grafana to map out the waves that it picked up on the module there. And this kind of goes back to Les's project earlier with the Raspberry Pi bird feeder camera. You could link up Grafana with that, Les, and keep an eye on things like temperature, time of day, and have access to the log of pictures that it's taking using Grafana.
Excellent.
Yeah, it's super, super useful. So what do you guys think? Would you use it for any of your Pi projects?
Yeah, I've never used Grafana at all. I've heard of it, but never used it. So I might give that a bash.
It's really easy. It's a lot easier than I expected it to be.
Yeah, I mean, I could imagine. Anton, could you see yourself using something like this with one of your projects?
Sorry again, but yes, I'm already doing that for the in-house quality, like air quality control for PM2. And as software engineer, like we use Grafana a lot. It's really a wonderful tool for the statistic visualization.
That's cool.
Yeah, I mean, it is important to be able to easily graph things. I know at one point years ago, I created a graphing tool for something, and I created in JavaScript and another one in like PHP, and being able to like figure out how to draw graphs from scratch is such a pain in the butt. Being able having something that can do a good job for you of graphing stuff, figuring out what the axes are, things like that, is so important. I cannot tell you how many hours I spent having stuff where the bar would somehow magically go off of that grid or something like that. So it's so many things we do involve visualization, and you can't beat it.
And what is wonderful, it actually one of the visualization tool which actually looks very good. because
Mhm.
there's a lot of them. The charts looks like black and whitish or a little bit off, but these one look very, very good. You can just put it on TV and enjoy the view.
Definitely.
Yeah, that is great. Thank you so much for sharing that, Ash. So we're almost at time for today, but I wanted to ask Anton, where can folks go to learn more about your project?
You can probably find me on Twitter, and there is going to be a link to GitHub where I'm posting all of the open source stuff I'm doing and my guys are doing too. So there's a bunch of libraries, and it's going to be a bunch of hardware projects as well.
Fantastic. Well, we look forward to covering those. Thank you so much for joining us. Thank you to everyone who watched and listened. As always, we are here on Tuesdays at 7:30 p.m. now, 7:30 p.m. UK time, 2:30 p.m. US Eastern time, and we will see everybody next week. Bye, everyone.
See you. Thank you for
Thank you.
inviting.